Hello, friend. I'm glad you're here in this small pocket of quiet. Let your shoulders loosen. Let your breath find its easy rhythm, like waves slipping over a moonlit shore. Nothing urgent is asking for you, just a soft room, a gentle voice, and the kind company of your own heartbeat. Tonight we'll cradle a question that glows without edges. What does it mean for something to be truly infinite? We'll wander slowly, counting without end, measuring horizons that keep stepping back, and listening for how a line can hold infinitely many points, yet fit on a fingertip. No rush. We'll rest beside paradoxes that feel like lullabies, and follow calm paths from the number line to the night sky, where distances stretch and still, somehow, feel close. If this quiet keeps you company, a light touch on like and a soft subscribe can help other travelers find their way here too, only if it feels gentle and right. For now, let your breath lengthen, your thoughts unspool, and your mind float like dust in a sunbeam. Close your eyes. We'll explore the mystery together, unhurried and warm. What do we touch when a thing has no end? The word infinity sounds simple, but the moment you hold it to the light, it slips like smoke. It sits on the border where imagination leans into science, sometimes a lantern, sometimes a pebble that trips the foot. From ladders of paradox that never quite finish, to the idea of a universe that stretches without fence posts, infinity keeps showing up where our reach meets the edge of our maps. It winds through the structure of space, the quiet tick of time, the energy of particles, and the question of how many worlds or possibilities might be resting just beyond what we can name. People have been looking up at the night long enough to wonder if the stars continue without limit. Philosophers worried at motion and space the way fingers worry a smooth stone. Later, when numbers learned to sing on chalkboards, mathematicians tried to write infinity into their grammar and found that it solved as many puzzles as it made. Physicists, standing at the cliff of their equations, sometimes watch the symbols run off toward infinity while the world itself refuses to follow. It is a mystery and a tool, a comfort and a riddle. Without it, our formulas would be smaller. With it, the universe becomes wider than our sleep. Set infinity gently on the floor and sit beside it like a quiet friend. Long ago, Zeno of Elea whispered a handful of questions that refuse to grow old. To cross a room, you first must walk halfway. Before you finish, you must travel half of what remains, and then half again, and half again, without end. If the halving never stops, how does anyone reach the far wall? In everyday life, feet do reach the other side, yet the paradox lays a small stone in the mind. Space can be divided forever, but motion somehow arrives. How do those two truths share the same room? Achilles racing a tortoise holds the same mirror. Give the tortoise a tiny head start. By the time Achilles reaches the place the tortoise once stood, the tortoise has pushed a little farther. When he reaches that new place, the tortoise has edged on again. The chase, by the logic, never concludes. Anyone who has watched a sprinter pass a plodding shell knows the world has other plans. Zeno wasn't trying to freeze our legs. He wanted to show that infinity hides inside the smallest act, a single step, and that common sense isn't always the final judge of how change unfolds. Elsewhere, other traditions braided infinity from different threads. In India, storytellers spoke of cycles vast beyond reckoning, worlds made, unmade, remade, the universe breathing in and out over spans too long for any calendar. A single kalpa was said to outlast the wearing down of a mountain touched by a silk cloth once every 100 years. The image is playful and deep. Time is a patient river, life is a passing eddy. In China, the Tao was described as boundless and nameless, a current under everything, without beginning or end. Along the Nile and under Babylonian skies, careful watchers took notes on stars that seemed to form a roof without edges, while the flood and the seasons returned with a rhythm that felt like eternity moving through ordinary days. Infinity in those places was not chalk and symbol. It was the lived cycle of night and day, water and wind, absence and return. Try to touch the border of the universe, and a fresh tangle begins. If there is a wall at the edge, what lies beyond the wall? If there is something, then the wall is not the edge. If there is nothing, how can nothing have an edge at all? The mind dislikes a hard ending and also dislikes the absence of any end. Infinity sits exactly at that uneasy fence line, asking us to breathe. Mathematicians of old drew a simple line between two shapes of the endless. One was potential infinity. You can always add one more, always cut a distance again. The other was actual infinity, an infinity that exists as a completed whole. Aristotle refused the second for the world he knew. To him, infinity was always a process, never a finished state. The echo of that idea still hangs in the air. When you count, you never arrive at infinity. You simply keep walking, each step promising another. Religious traditions often used infinity as a way to point toward the sacred eternal, without boundary, not subject to the weathering of time. To call a deity infinite was to say it sits outside decay and measure, beyond the reach of ours. The word became a kind of mirror for human life, a reminder that our days are counted, and yet our thoughts lean towards something uncountable. Then someone laid down the first stones of counting 1, then 2, then 3, then 4, then 5, and found no opposite bank to the river. Children realize this early and ask what lives beyond the biggest number. The honest answer is that there is no biggest number. Numbers are stepping stones across a stream that never meets a far shore. You can always take another step. That is potential infinity in its most familiar clothes. Now a small game. Compare all whole numbers with the even ones. Instinct says the whole crowd must be larger than the half that are even. Yet it's easy to pair them perfectly. 1 with 2, 2 with 4, 3 with 6, and so on, forever. The pairing says their sizes, in the infinite sense, are equal. The same trick works with odd numbers, square numbers, and even prime numbers. Each stretches without end. Each can be matched 1 for 1 with the full list. Infinity does not shrink simply because you remove a steady pattern of its members. It can be shaved and still remain what it was. This soft elasticity puzzled people until Georg Cantor stepped closer. He refused to blink. He studied infinity head-on and found that not all infinities are alike. Some can be counted in a list, no matter how long the list must be. Others cannot. Whole numbers make a countable infinity. You can imagine lining them up and labeling each with its position: first, second, third. Fractions seem denser between any two whole numbers, live infinitely many. But with a clever diagonal path through a grid, Cantor showed that fractions, too, can be listed without missing any. Each fraction eventually gets its turn. Then he looked at the real numbers, which include not only neat fractions but also tangled decimals that never settle, like square root 2 or pi. The diagonal trick, turned one more time, revealed something startling. No matter how you try to list the real numbers, some will always escape. The set of real numbers is unlistable. Its infinity is strictly bigger than the infinity of whole numbers. Cantor called the sizes of sets their cardinalities, and the size of the real line he named the continuum. Infinity stopped being a single ocean and became a tower of levels, each floor dwarfing the one below. Not everyone welcomed this view. It felt like separating mist into boxes, yet Cantor's framework endured, and in time, it became the ground floor of modern set theory. Today, much of mathematics walks on those boards. Listen to infinity for long and it begins to sound less like contradiction and more like the natural fold and drape of a fabric too wide for any table. To feel the strangeness with a smile, check into Hilbert's Hotel, a thought experiment with infinitely many rooms, numbered 1, 2, 3, and so on. Tonight, every room is full. Yet, a new guest arrives. The manager simply asks the guest in room 1 to move to room 2, the guest in 2 to move to 3, and so forth. Room 1 opens. The newcomer rests. If a bus carrying infinitely many new guests pulls up, there's still no trouble. Ask every current guest in room N to move to room 2N. Now all the odd-numbered rooms are free, infinitely many of them, and the infinite bus unloads with ease. Infinity, it seems, is endlessly hospitable. But checking out is stranger. If everyone leaves except the guest in room 1, the hotel still contains infinitely many occupants, because the instruction, everyone except room 1, can be read in different infinite ways. If all guests in even rooms depart, the odd rooms hold an infinity that remains. Subtracting infinity from infinity depends on how you do it. The result isn't a single number, but a mood. The rules we trust for apples falter in the long hallway of endless quantity. It isn't chaos. It's a different geometry of counting. These aren't just parlor games. Calculus, the quiet engine under much of modern science, relies on the idea of pushing steps smaller and smaller, brushing up against infinity without holding it. To find a slope at a point on a curve, you imagine a step that shrinks toward nothing and watch the ratio of rise to run settle into a limit. The answer isn't infinity. It is the shadow that infinity throws on the wall. Infinite series, sums that never end, can drift toward a tidy value. Add 1, 2 plus 1, 4 plus 1, 8 plus, and the total approaches 1. Infinity hums in the background, and in the foreground, you get something you can use to build a bridge or time a pendulum. In physics, infinities sometimes flare like warning lights. A calculation might spit out an infinite energy or an infinite density, which is the world's way of saying the model has reached beyond its license. Physicists respond with renormalization, cleaning the math and changing the scale of view, or by seeking a deeper theory where those infinities resolve into finite shapes. These aren't disasters. They are milestones that tell you to redraw a shoreline on your map. The universe rarely blows up because a symbol grew too large. More often, it nudges us to tell a subtler story at a better scale. Let the number river slide by again 1, 2, 3, and notice the gentlest truth of all. Infinity is already present the moment you begin, and it sits calmly, patient as noon shade. It doesn't demand to be grasped as a single object. It only asks you to keep stepping, each number another stone. Behind you, the old stories set the rhythm. India's breaths of creation and rest, China's nameless current, Egypt, and Babylon's endless roof of stars. Infinity lives not only in proofs, but in the ordinary return of light and dark, harvest and thaw, low tide and high. The question of boundaries returns like a tide. If the cosmos has a fence, what stretches beyond it? If nothing, how does nothing have an outside? If something, the fence was only a doorway. We are human, which means we worry both about a last page and about a book that never ends. Infinity helps us bear that double ache by offering a quiet compromise. We need not answer at once. We can walk, we can rest, we can look again. Aristotle's line that infinity is a process, not a thing, feels like a lullaby when you say it softly. Infinity is the horizon. You cannot hold it, but you can face it and move. Each +1 is a footstep. Each cut in half is a breath. There is no need to twist the mind into pictures it cannot honestly draw. It's enough to admit there are matters that widen as you look, paths that lengthen as you walk, shores that recede as you approach. Remember the gentle pairing of numbers. What seemed impossible, that half equals the whole, is true in the realm of countable infinity. Remember Cantor's leap. Some infinities can't be listed at all. Between any 2 points on a line lies a forest too thick to name one by one. Smile at Hilbert's warm-lit lobby, always able to make room. None of it is meant to overwhelm. These tales soften stiff habits of thought so that imagination can cross a small bridge into a field of understanding. At the other corner of the blanket, limits murmur. As distances between two measurements diminish, as you study change on the scale of almost nothing, curves behave and pass you a number. Infinite sums learn manners and lean toward a single value. The series 1 2 plus 1 4 plus 1 8 plus bows toward 1, like a bead of water settling steady on glass. Infinity can be the method while finitude is the result. Still, infinity will never become a drawing you can finish. It stays slippery, half hidden in words, yet it changes how you think about everything. A single number can open a door to unending more. A path that can be divided forever still leads you to the far side of a room. A sky without walls can feel like company rather than empty space. Let infinity unfold slowly, like a horizon relaxing as the eyes grow kind. Ask what it means, and you've already begun. The journey doesn't need a signpost or a deadline, just the unhurried patience of a curious mind. If at times the thought of never ending feels too large, remember the tender side of infinity. It allows perfect pairings between sets that seem unequal, teaching you to set aside everyday instincts about big and small and listen for a different kind of sameness. It shows how a process can carry the outline of a whole within it, not as a completed monument on a table, but as a promise standing just behind you, nodding each time you take another step. When equations shout an infinite value, it may only be their way of asking for a new lens, a fresh scale, a better story. The world is patient with our mistakes. It doesn't punish us for seeing too far. It invites us to look again from closer in. Infinity plays a double role, a boundary where reasoning stumbles and a gateway where understanding steps through. We don't need to master every layer of the endless. A few stones placed on the water are enough to see the pattern of ripples. Zeno shows the path of half steps. India and China lend the breath of long cycles. Babylon and Egypt lay us beneath a sky without walls. Cantor builds invisible stairs. Hilbert leaves a golden lamp by the check-in desk. Calculus sets a candle on the corner of the table, bright enough to write a limit that engineers can trust. Each story is a thread, Woven together, they make a blanket wide enough for sleep. Infinity doesn't ask for belief as if it were a charm. It asks for listening, the kind that notices the soft consistency beneath the strangeness. Some endless sums drift toward a crisp number. Some sprawling sets match the size of the hole they came from. Some infinities tower above others, the way winter's sky feels deeper than summer's, though both have no ceiling. Add one, never runs out. Divide again, never reaches a final grain of distance you cannot split. And when the room returns to its first quiet, that gentleness lingers like a hand on your shoulder, an invitation to keep going, little by little, without needing to arrive tonight. In that permission, fear thins. What we call infinity becomes a softer word for patience. From that quiet, a simple, everyday question lifts like a whisper. What comes after the biggest number? Each time someone asks it, a fingertip grazes the endless. Infinity isn't a far-off cliff at the edge of the cosmos. It's tucked inside the ordinary habit of saying one more. Time moves through that habit like a quiet river, steady, unhurried, carrying each life from dawn to dusk. It feels simple, yet it is the most mysterious room we live in. It slips past without effort, smooth and relentless, leaving only memory behind us and possibility ahead. Touching the thought of the unbounded, minds have always turned to this river and asked, does it have a source, a mouth, or neither? Could it flow back without beginning and forward without end? Or is there a hidden wall no clock can cross? Many old stories chose a circle over a line. On temple steps and riverbanks, people watched seasons loop, the sun rise and fold itself back into night. Generations arrive and depart like tides. In Indian cosmology, ages called yugas breathe creation in and out on spans so large the calendar grows quiet. Greek thought imagined eternal recurrence, a universe repeating itself again and again, not because it is bored, but because its pattern is deep. The wheel has no last spoke. Philosophers tied gentle knots in the idea of cause. If every event leans on a cause, and every cause leans on something before it, where does the leaning start? Some said, it never does. The chain is endless. Others said, an infinite regress can't stand, that there must be a first spark. Aristotle leaned toward an eternal time. From nothing, nothing comes. Much later, theologians spoke of a single beginning, a moment when time itself was invited into being. Modern cosmology turned the dim lamp brighter. Evidence points to a real beginning for our visible history, the Big Bang, roughly 13.8 billion years ago. Not an explosion inside space, but the growth of space and time themselves, from a state of staggering density and heat. In that picture, asking what came before is like asking what's north of the North Pole. The question slides off because before belongs to the very thing being born. Yet, beginnings have a way of opening new doors. Some models imagine a bounce, a universe that contracts, then springs outward, again and again, time running back through countless cycles. Others draw the scene of eternal inflation, a vast field budding bubble universes without end, each with its own local story, ours just one chapter in an unfinishable library. A single start remains, perhaps, but not for the whole ensemble. The outward flow of time meets the universe's long future with the same hush. If expansion keeps its pace, stars will burn their last fuel. Galaxies will drift apart like lanterns carried to different valleys. and the cosmos will thin into cold quiet. This heat death is an infinity of time, with very little to say, energy spread evenly, novelty scarce. If dark energy changes its character and tugs harder, there's a more dramatic script sometimes called the Big Rip, where even atoms lose their grip as space stretches faster than bonds can hold. Either way, the question isn't only how long time lasts, but what kind of story it can still tell. Daily life writes a smaller version. To a single person, time feels like a straight arrow from first breath to last, a line you can point to. From farther out, waves of people keep arriving, households fade and return, and the ocean of time does not run dry. A life is a finite cup. The river that fills it invites larger questions. Is there a spring we cannot see? A sea we cannot reach? Eternal recurrence adds a quiet dare. Friedrich Nietzsche, echoing older Greek whispers, asked us to imagine living the same life again and again, every joy and every ache repeating forever. Not a physics claim, but a mirror held to the heart. Would you still say yes if this night, these choices, returned without end? Infinity turns personal there, not as a number, but as a way of holding what is already in your hands. Physics carries its own puzzles into the long hallway. If time is endless, even rare events become inevitable, somewhere, sometime. Given enough room and hours, matter can arrange itself in every allowed pattern. Another Earth could blossom in a far corner. Another you could sit under a similar lamp, perhaps choosing a different bedtime story. The thought stretches imagination and tugs at the rules of probability, raising delicate questions about meaning in a timeline that never quits. And still, time keeps its composure. No one can step outside the river to see whether it loops, ends, or runs forever. Clocks only point forward, memories only point back. The rest stays behind a soft curtain. Scientists craft models, philosophers knit arguments, poets sew pictures, and somewhere the truth keeps walking, a step ahead of every calendar. What settles, even without answers, is time's role in shaping experience. Without it, motion would have no sequence, change no story, life no rhythm to dance to. Whether time stretches without bound or began in a single spark does not shrink its wonder. The question enlarges it. Time isn't just numbers turning on a dial. It's the stage on which the world remembers to move. The night sky adds another layer. A clear evening invites the oldest question. Does the starfield ever end? Is the universe an infinite canvas, or simply vast and curved back on itself like the surface of a sphere, where you can travel forever and never strike a wall? The first task is gentle and precise. Separate what can be seen from what may exist. The observable universe is a bubble centered on the observer, about 46 billion light years in every direction, not because anything outran light, but because space itself has been stretching while light was en route. Beyond that horizon likely lies more, perhaps much more. The visible is a balcony. The view past the railing is unlit, not absent. Geometry frames the question with a calm hand. General relativity says matter and energy tell space how to curve, and space tells matter how to move. Three broad shapes beckon. With positive curvature, space is like a sphere, finite, yet unbounded, no edge to fall from, and in principle, a long voyage could return to its start. With negative curvature, space is saddle-shaped, opening outward forever. With perfect flatness, space is neither bowl nor saddle, an endless plain with no curvature at all. Each shape carries different possibilities for size, for the path of light, for how shadows and distances behave. Deciding among them is part of the slow joy of cosmology. However the verdict comes, the feeling remains the same. Time and space draw the frame, and inside that frame we find our lives. Infinity hovers not as a thread, but as a horizon. The river flows. The stars keep their distances and their patience. Whether the road is a line without end or a circle that gently returns, it carries each step as far as the step can go. On the quiet edge where certainty softens, imagination has room to breathe, and that breathing is part of why the questions are worth asking at all. And the sky, patient as ever, offers an answer in its oldest light. The cosmic microwave background, the faint afterglow of the Big Bang, holds tiny ripples, gentle temperature specks like grain in old film. Reading their pattern lets us infer how space itself is bent. So far, the pattern leans toward flatness, with only a small margin left for a curve too subtle to catch. Flat, here, doesn't mean dull. It means that on the grandest scales, triangles keep Euclid's promise, and parallel lines neither meet nor drift apart, a quiet confirmation that the frame is wide and even, and that the horizon can keep its distance with grace. Flatness hints that the universe may be infinite, or at least so vast that any bend hides beyond our reach. The other options aren't ruled out. The door is still ajar. Space could be finite, yet so enormous that its curvature whispers below the threshold of our instruments. Finite, but unbounded, is a hard picture to hold because we're used to edges. Think of Earth's surface. It has a limited area, yet you can walk forever without finding a cliff where world ends. Trade that two-dimensional skin for three-dimensional space, and you get a cosmos that loops without walls. Travel perfectly straight, and in principle, you might come home from the other side, though the journey would be so long that no ship and no ray of light has had time to complete it. Horizon effects complicate the view. Because space is expanding, the most distant regions recede faster than light, not by breaking relativity, but because it is space itself that stretches, carrying galaxies like lanterns on a widening river. Those realms are cut off. No matter how patient we become, some parts of the universe remain forever beyond our horizon. If infinity lives out there, we cannot confirm it directly. We dwell in a finite bubble, ringed by the unknown. More exotic possibilities stay on the table. Space could wrap in unexpected ways, like a three-dimensional video game world where stepping across one boundary returns you through another. In such a topology, light from a single galaxy might circle the cosmos and arrive at our eyes from multiple directions, making ghostly duplicates in the sky. Astronomers have searched for the telltale repetition of large-scale patterns, a cosmic wallpaper motif that would give the shape away. So far, the sky declines to repeat itself, at least on the scales we can probe. If space is truly infinite, the questions turn profound and a little dizzying. In an endless expanse built from a finite alphabet of particles, every arrangement that can occur will occur, and not just once. Somewhere unimaginably far away, another Earth could be tucked into another arm of another galaxy. Another you could be hearing these words, perhaps with a different mug in hand or a different song in the background. That isn't fantasy for its own sake. It's a straightforward implication of infinity, married to a finite set of building blocks. We may never reach those distant cousins, but the thought stretches the mind in a way that feels both playful and solemn. Yet infinity brings arithmetic headaches. An infinite universe would contain infinite stars, infinite galaxies, infinite energy spread across endless rooms. What becomes of probability in a hallway with no end? If there are infinitely many versions of something, what does more likely mean? Physicists wrestle with these measure problems and sometimes suggest that theories should avoid unbridled infinity when they can. Still, finitude has strangeness of its own. If the universe is like a sphere, what lies outside it? Nothing in the usual sense, because space itself is the surface. Asking for an outside is like asking what is north of the North Pole. The question dissolves as soon as you try to hold it. Either way, humility settles in. Whether infinite or simply too large to name, the universe outpaces any voyage we could make. Our observable bubble is all we will ever touch, yet it is generous with clues. Early light carries whispers of curvature, and the way galaxies lace themselves across the sky hints at the geometry underneath. Certainty may never be ours, but we can circle closer with every observation. Like a ship sketching a coastline it will never fully see. Stand under a clear night, and the mind naturally leans outward. Does the star field roll on forever, or does it fold back on itself like a great loop? Perhaps the truth will always stay a step ahead. The wondering is still a journey, and the journey is part of the answer. Infinity in space invites imagination to walk beyond the visible and keep walking, knowing the horizon will keep its courteous distance. A century ago, many pictured a still cosmos, galaxies pinned like cold jewels to velvet. Then came a quiet earthquake. In the 1,920 seconds, Edwin Hubble measured the light of distant galaxies and found a pattern. Almost all of them were moving away, and the farther they were, the faster they receded. It wasn't that we sat at a special center. It was that space itself was stretching. The universe was expanding. Run that film in reverse and everything crowds closer. Keep rewinding and you reach a frame where the densities and temperatures soar. Not an explosion into empty space, but the expansion of space and time from an earlier, hotter, denser state. That is the Big Bang, the start of our observable history. Expansion is better pictured not as shrapnel flying outward, but as raisins in rising dough. Every observer sees other raisins drift away because the dough swells everywhere at once. Hubble's discovery was the opening line, not the whole paragraph. As cosmologists listened harder, they heard puzzles the bare expansion could not resolve. Chief among them, uniformity. Why is the cosmos nearly the same temperature in directions that, under simple expansion, could never have shared a past? The proposed answer was bold and, in hindsight, elegant: cosmic inflation. In a sliver of the first second, space is thought to have ballooned at a furious, exponential rate. This wasn't galaxies racing through space. It was space itself growing so quickly that regions once neighbors were flung far beyond each other's horizons. Inflation smoothed the cosmos on large scales and, at the same time, amplified tiny quantum jitters into the seeds of structure. Evidence for this story crept in and then stood tall. The particular freckles in the cosmic microwave background, their sizes and strengths matched the predictions of inflation with striking grace. The same data point toward near-flat geometry and a sky almost uniform, yet sprinkled with just the right irregularities to grow stars, clusters, and filaments. Inflation can sound extravagant, but it explains why the universe looks so calm from far away. while remaining lively up close. As often happens in science, one answer opened a hallway of new doors. Detailed models suggest inflation may not switch off everywhere at once. Some regions stop inflating and become normal, expanding space like ours. Elsewhere, the process continues, budding new regions again and again. This is eternal inflation, a cosmic field forever seeding bubble universes. Each bubble could inherit slightly different physical settings, particle masses, force strengths, even the shape of space on large scales. Our observable cosmos may be one such bubble in a wider froth. That picture blends naturally into talk of a multiverse. It sounds radical, but here it follows from the mathematics of certain inflationary models rather than wishful thinking. Not everyone is persuaded. If other bubbles are forever beyond our reach, some worry the idea drifts toward speculation. Others reply that there may be faint fingerprints, subtle scars in the microwave background from ancient bubble brushes that could, in principle, tip the scales. The debate is lively and honest, which is exactly how science breathes. Meanwhile, the expansion has news of its own. In the late 1990 seconds, observations of distant supernovae revealed that galaxies aren't just receding, they're receding faster with time. Some unseen pressure, dark energy seems to drive an acceleration. We don't yet know its nature, only its effect. The fabric continues to stretch, and more galaxies will drift past our cosmic horizon, sliding out of view for good. In that sense, our observable universe is shrinking even as the whole expands. The portrait that emerges is both lonely and generous. We live in a restless cosmos, stretching in every direction. The stars we can see are a tiny fraction of what exists, and with each passing epoch, more will slip beyond sight. Infinity may never be something we can measure directly, but expansion tells us the stage is larger than any story we can finish. Whether space is truly endless or merely enormous past our comprehension, it dwarfs our corner and still invites us to read its clues. It's astonishing that this grand arc began with careful measurements of faint smudges through glass galaxies reddened by motion, clustered like frost on a window. From those modest beginnings to inflation's sweeping narrative and the tentative whispers of a multiverse, the story of expansion shows how small pieces of evidence can reveal vast patterns. The universe is not a still stage, but a living weave, unfolding with a momentum that seems, for now, unstoppable. Infinity may hide beyond every horizon or wrap quietly in a loop. Either way, the night reminds us there is always more than we can hold, and that the act of wondering is itself a way of traveling. And within that vast, widening fabric, some threads are pulled so tight they turn the gentle curve of gravity into a clenched fist. Black holes are where the ordinary handshake becomes a grip, strong enough to fold light. The same force that keeps your feet on the floor can, with enough mass packed close, turn familiar space into something extreme. A heavy star spends its fuel, can't hold itself up, and the collapse deepens until escape is no longer possible. What forms is simple to name and hard to picture. A region so dense that even a beam of light cannot climb away an island of night inside the ocean of night, reminding us that infinity lives not only in distances without end, but also in depths without return. Einstein's equations tell this story with unnerving calm. Squeeze matter into a smaller and smaller space, and the curvature of space-time rises like a tide. Push the math far enough and it points to a singularity, density without limit, curvature without limit, a place where the fabric itself stops behaving like a fabric. At that point, the rules we trust lose their grip. Infinity walks into the room not as poetry, but as a warning flag in the equations. What does that flag mean? It may be less a real point of infinite everything, and more a sign that our map ends here. General relativity guides us across galaxies and orbits with breathtaking accuracy, but it is not the whole story. The small-scale laws, quantum mechanics, speak a different dialect. Many physicists expect that when gravity and quanta are finally married in a single framework, the fierce point at the center will soften into something finite, spread, or transformed. For now, the singularity remains hidden behind a boundary we can name but not cross. That boundary is the event horizon, the quiet shell that marks the point of no return. Cross it, and every possible path points inward. From the outside, it looks like a dark sphere hanging in space, an outline where light itself goes silent. To a distant watcher, a falling object seems to slow and dim and almost freeze at the edge. In its own time, it plunges quickly toward the center. 2 clocks, 2 stories, one stretching toward the endless, one rushing to an end. Infinity slips quietly into perception here, in the way time can lengthen or compress, depending on where you stand. Black holes come in sizes that feel like riddles. Some are a few dozen kilometers across, born from single stars. Others, supermassive, sit in the hearts of galaxies, weighing millions or billions of suns. They stir stars, shepherd gas, and power jets that lance across thousands of light years. Imagine watching from a safe distance as starlight arcs around a dark circle, like bright threads drawn over glass. Imagine the hush of a clock that seems to linger forever at the horizon, never quite falling through. Beauty and unease share the same view. What waits at the center is still an open book. Loop quantum gravity hints that space and time may have a smallest grain, like a fabric whose weave cannot be squeezed past a certain tightness. If so, the collapse might bounce or resolve before infinity arrives. String theory imagines tiny vibrating strings rather than point-like particles, adding structure that could tame the blow-up. No verdict yet, only a consistent whisper. Infinities in our math often mark the edge of a theory's authority, not the edge of reality itself. Even without seeing inside, black holes make their presence known. Matter swirling toward the horizon heats until it shines in X-rays, sometimes outshining an entire galaxy for a while. When 2 black holes merge, the geometry itself rings. Those ripples, gravitational waves, pass through us as gentle changes in distance that our instruments can now hear. Each detection is a small, perfect note. 2 dark bodies collided, and space-time sang. There is also a long, patient ending woven into the story. Quantum effects near the horizon suggest that black holes can slowly leak energy. Hawking radiation over spans so vast, it makes patience into a kind of art. Given enough time, the black hole could evaporate, returning its hoard to the wider universe, grain by grain. If that is true, infinity here behaves less like a final wall and more like a mirage that recedes as our understanding sharpens. Step from the cosmic to the microscopic, and infinity changes its costume. but keeps the habit of appearing where we least want it. Quantum physics describes particles as ripples in fields that fill all of space. Electrons are excitations of the electron field, photons of the electromagnetic field, and so on. When particles interact, the calculation gathers contributions from virtual ripples of every possible energy. Add up too much of that tower and the numbers swell without bound. The answer, left untouched, becomes infinite. In the mid-20th century, this looked like disaster. How can a theory that yields infinity be trusted to predict a cross-section, a magnetic moment, a spectrum line? The rescue was both humble and brilliant. Renormalization. It says that the raw parameters in our equations, mass, charge, field strengths, aren't what we directly measure. We redefine them so that the infinite parts cancel against one another, and what remains matches experiments to absurd precision. The process isn't a trick, it's an acknowledgement that what we observe is always shaped by the scale at which we look. With this taming, quantum electrodynamics became a jewel of accuracy, its predictions confirmed to many decimal places. The wild horse wasn't broken. It learned to pull the cart. Another infinity lurks in a place that sounds empty, the vacuum. In classical thinking, the vacuum is nothing. In quantum thinking, nothing is restless. The uncertainty principle won't allow perfect stillness. It requires a low hum of fluctuations. Pairs of virtual particles flicker in and out, tiny loans of energy, paid back almost at once. This background activity is called zero-point energy. Try to total it across all the possible vibrations of all the fields, and the sum explodes another infinity, staring from the page. We know the vacuum cannot carry infinite energy. If it did, the universe would not look anything like the one we inhabit. So, we bring in cutoffs, limits that say our equations shouldn't be trusted beyond certain scales, or we arrange a second infinity of opposite signs so that the two cancel. Another act of renormalization. Even with these tools, a quiet puzzle remains. Observations suggest that empty space does have some small, positive energy, dark energy, that pushes the cosmic expansion to accelerate. The number we measure is tiny. The naive quantum estimate is enormous. Between those two lies one of the deepest gaps in modern physics, a reminder that tamed is not the same as understood. The pattern repeats across scales. When a calculation spits out infinity, it may be pointing toward new physics or toward the need to change perspective. For black holes, it hints that quantum gravity has more to say. For particle fields, it teaches us to measure carefully and define what matters at the energies we can reach. In both scenes, infinity is less a monster and more a signpost. You've reached the border of your current map. Draw a finer one. None of this lessens the awe. Picture a star's core folding into darkness until time itself stretches thin. Picture the vacuum trembling with quiet activity, the universe's baseline heartbeat. Picture a merger a billion light years away, and the faint shiver it sends through the room you're in. The universe does not promise comfort. It offers wonder, and with it, the gentle discipline of better questions. If singularities are real, nature hosts rooms where our present logic breaks. If they are not, they are still precious markers showing where the next understanding should begin. Black holes hide, yet they govern. Quantum fields confuse, yet they predict. The infinities that surface along the way are not verdicts, they're invitations to refine the story until the numbers calm and the picture sharpens. Somewhere beyond the horizon of a galaxy's core, and somewhere beneath the threshold of a proton's whisper, infinity is doing what it always does in good science, pointing to the edge and asking us to keep walking. Follow that hint into the quietest place. We know the vacuum and the invitation becomes a riddle. The simplest quantum estimate says empty space should roar with energy. Our instruments, listening carefully, hear only a hush. The amount we measure is wildly smaller than the naive sum. The mismatch isn't a gentle error. It misses by roughly 120 orders of magnitude, a gap so large, it's often called the worst prediction in physics. It's as if the math shouts infinity, where the universe whispers barely a murmur, a soft reminder that the endless still has the upper hand here, and that our next, better question is waiting in the space between the shout and the whisper. Even so, the vacuum is not a blank silence. Its fluctuations, though invisible, can lean on matter with a real touch. Place two uncharged metal plates very close together, and the quantum buzz outside them presses a little harder than the buzz between them, nudging the plates inward. This Casimir effect has been measured in the lab. The calculation behind it asks you to subtract two infinities, the energy of empty space far away and the energy confined between the plates, and keep the finite difference that reality allows you to touch. A neat alchemy, infinity in the equations, a measurable force in the hands. From these small pressures to the grand weave of forces, quantum field theory has grown to describe electromagnetism, and the weak and strong nuclear force is the standard model that has survived every test we've given it. The price of that success is constant gardening. Infinities sprout in the calculations like stubborn weeds. Renormalization is the careful pruning that keeps the flowers. You redefine quantities, such as mass and charge, so the wild parts cancel, and the predictions that remain match experiments with absurd precision. It isn't a cheat. It's a way of speaking the language the world actually understands at the scales we can reach. There is still a hope, quiet but steady, that a deeper theory will make those infinities fade like morning mist. Many suspect that, at unimaginably small distances, space and time are not perfectly smooth, but come in discrete steps, pixels on a screen, so fine the eye cannot see them. If nature is granular at the Planck length, around 10 to the power of negative 35 meters, and the Planck time, around 10 to the power of negative 44 seconds, then the blow-ups that come from assuming a perfectly continuous fabric might simply evaporate. String theory replaces point-like particles with tiny vibrating strings, softening sharp corners and calming some divergences. Loop quantum gravity imagines space itself woven from finite loops, a network that refuses to be crushed to nothing or inflated to infinity. None of this is settled, but the common instinct is clear: make peace with the endless by building a world where it does not need to appear at the deepest level. It's tempting to treat infinity as a flaw in the code, a bug to be patched, yet it is also a guidepost. Each time it rises in a calculation, it points to a boundary of our current understanding. Once, the infinities inside the hydrogen atom looked fatal. Renormalization taught us how to listen better. The enormous energy we naively assign to empty space presses us toward better questions about dark energy and the structure of space-time. Here be dragons, the old maps warned, not to forbid travel, but to stir careful courage. Infinity doesn't only stretch outward with the galaxies, it also turns inward, burrowing into the very small, Take a stick, break it in half, break the half again. Can you continue forever? Or does the world say, no farther, and hand you an indivisible piece? Democritus answered, with atoms uncuttable, seeds combining to make everything we see. Others, including Aristotle, trusted the smoothness of experience. Water glides without grain. Matter must be continuous and endlessly divisible. Both views felt right in the hand. Atoms neatly answered some old paradoxes. Continuity matched the way the world looks to the eye. Centuries later, a new tool arrived that leaned on the idea of the infinitely small. Calculus, developed by Newton and Leibniz, gave language to motion and change with a breathtaking gentleness. Take a step that shrinks and shrinks, approaching zero without quite arriving, and watch a limit form. With that, slopes appear, areas gather under curves, and planets find their paths. Early critics teased these ghosts of departed quantities, suspicious things that were neither quite zero nor comfortably finite. Over time, the discipline of limits gave the ghosts a home. We don't pretend the infinitesimal is a physical crumb we can place on a scale. We treat it as a process, an approach, and the results are as solid as bridges and satellites. The physical world kept its own counsel. In the 19th century, the discovery of atoms gave Democritus his nod. Matter is discrete, made of atoms that can be named and counted. Those atoms revealed smaller pieces. Protons and neutrons carry quarks. Electrons, as far as we know, have no internal parts. The dream of an ultimate building block glowed for a while. Then, quantum theory changed the mood again. Particles behaved like waves, smeared in space, existing as probabilities until measurement sharpened them. Reality was neither perfect grain nor perfect silk. It was both. Waves with discrete packets of energy, fields with quanta. At the Planck scale, our two great stories, quantum mechanics and general relativity, talk past each other. Space-time might lose its smoothness there, becoming lacy, foamy, pixelated in a way no microscope can see. Does that mean there is truly a smallest length and a briefest moment? Loop quantum gravity says yes. String theory suggests the same in its own way, with strings on the order of the Planck length. Others advise caution. Perhaps the Planck scale marks only the edge of our current map, not an actual graininess in the world. A new framework could someday carry divisibility even deeper without courting contradictions. Either way, the implications are deep. If space and time are granular, infinity is fenced at the bottom. There are no endlessly small distances, no eternally shrinking instants. If reality is continuous, infinity hides in every crack, always ready to emerge as you divide again. In practice, we live with both pictures. Calculus assumes smoothness and works wonders, from aerodynamics to blood flow. Quantum mechanics insists on discreteness where it matters and stops the worst infinities from running wild. Physics today is a grace note between the infinite decimal and the finite quantum, smooth waves and counted quanta sharing the same quiet room. For most days, these debates drift far from the kitchen table, yet they carry a kind of comfort that a simple question, can I keep cutting this in half forever, still engages some of the best minds on earth as proof that infinity sits close to the roots of understanding. Picture two visions and let them both breathe. In one, reality bottoms out. Space and time come in indivisible grains, no smaller steps allowed. In the other, Every line can be split again, every moment subdivided without end. The infinite decimal, a property of nature itself. Both are awe-making. Both remind us that even inside the smallest measure, the endless knows how to appear. There is another soft word the universe uses to talk about direction. Entropy is often thrown around as a synonym for messiness, but in physics, it means something precise. How many different microscopic arrangements can hide beneath the same larger appearance? A perfect stack of cards has low entropy, only a few ways to look exactly that neat. Shuffle them, and the number of hidden arrangements explodes. Entropy rises. The second law of thermodynamics says that for a closed system, entropy does not decrease overall. It can hold steady for a while. It can dip locally at the cost of a rise elsewhere. But given time, it climbs. This simple rule gives time its arrow. Watch a glass fall and shatter, and you know the film is playing forward. The shards won't leap up and knit themselves into a cup, even though nothing in the smallest equations forbids it outright. The odds are so tiny that we treat them as absent. Order spills into disorder. Heat spreads. Perfumes do not unmix. The universe, in that sense, remembers which way is later, because the number of ways to be disordered is so much larger than the number of ways to be crisp. Entropy touches the earlier questions in a gentle loop. The vacuum's energy mismatch, the Planck scale debates, the taming of infinities. Each is a conversation about counting and scale. How many modes exist in empty space? How finely can space-time be sliced? Which infinities are signals to redefine, and which are signs to replace the story? Each answer, provisional and careful, keeps the arrow pointing on, reminding us that understanding grows by smoothing contradictions into limits and by turning impossible totals into differences we can measure. So the endless is not only oceans and horizons, it is also the breath inside equations, the quiet subtraction that leaves a force in a laboratory, the almost zero that guides a bridge's curve, the faint energy of empty space that nudges galaxies apart. Sometimes infinity behaves like a mirage we approach but never touch. Sometimes it is a lantern we hold for a while, bright enough to take the next step. And while the word can feel cold and abstract, it keeps us company in warm ways, in the way water swirls and settles, in the way a cup cools, in the way night spreads across a sky that may or may not go on forever. If the deepest theory someday banishes infinity from its basement, the journey there will still have been shaped by the places infinity appeared and held our gaze. If, instead, the endless remains woven into the final fabric, we will learn to live with it the way sailors live, with the horizon never reached, always useful. Either way, the work is the same. Listen for where the numbers shout too loudly. Look for the scale where they soften, and keep the story gentle enough to match the world it hopes to describe. In that gentleness, the endless becomes less a threat and more a guide, pointing forward as time does, quietly, steadily, and with just enough light to see the next few steps. Stretch the second law across an endless calendar, and it sketches a stark horizon. If entropy keeps rising, does it hit a ceiling? It does, and the view at the top is the heat death of the universe, a future so thoroughly evened out that there are no temperature differences left to push anything forward. Over spans that make centuries feel like single breaths. Stars exhaust their fuel, galaxies dim and thin, and energy spreads until every place looks like every other. entropy reaches its maximum, not because energy disappears, but because it is smeared so evenly that no work can be coaxed from it. No gradients, no engines, no sparks for new stars or the chemistry of life. A long, cosmic hush. The clocks for this story are enormous. Suns live for billions of years. The dark remnants they leave can last far longer. Black holes, the most patient keepers of time, slowly leak their mass through Hawking radiation. Even the giants take more than 100 years to fade. After that, the universe drifts in a sparse night, particles rarely meeting, space expanding, and entropy settling into its final plateau. In an endless future, the second law levels everything. Infinity becomes a desert of stillness. Yet infinity loves to tuck exceptions into the margins. Given unbounded time, even the nearly impossible can become inevitable. One such oddity is the Boltzmann brain, named after Ludwig Boltzmann, who taught us to think of entropy as counting microstates. In a high-entropy universe, tiny random fluctuations are common. Extremely orderly ones are fantastically rare, but not forbidden. Wait long enough, and the dice may land just so. A cluster of particles could, by accident, assemble into something complex, even into a brain that carries a full set of memories about a life it never lived. It might flicker on for a moment, think a thought, and then dissolve back into thermal fog. Absurd as it sounds, the mathematics doesn't ban it, and that opens a troubling window. If the universe lasts forever, and such minds arise infinitely many times, are they more common than observers like us, who grew from stars and oceans and time? If so, can we trust our memories, our science, our sense of having a past? Are we the product of a long, low-entropy history, or a brief spark in a future of equilibrium? Most physicists find this conclusion intolerable, a signal that our picture of entropy, or cosmology, is missing a key piece. Perhaps the universe does not, in fact, last forever in a way that allows such fluctuations to dominate. Or perhaps the space of possible states is more constrained than the naive counting suggests. Another strange thread is recurrence. In a finite system allowed to run forever, states will repeat. Shuffle a deck long enough and every arrangement eventually appears, including the pristine order you started with. If the universe has only a finite menu of states but an infinite stretch of time, conditions arbitrarily close to today's could return. The arrow of time would still point forward, entropy would rise between repeats, but the scenery, given aeons upon aeons, could loop. Entropy also places a quiet question at the very beginning. The Big Bang wasn't only hot and dense, it was extraordinarily low in entropy compared to now. That feels backward. How could the start be more ordered than the present? Gravity complicates the story. Smoothness under gravity is not the same kind of disorder as smoothness for a gas in a box. A nearly uniform early universe may actually represent a very special, highly ordered configuration, one that allowed structures to form later. Another possibility is that our visible cosmos is a rare low-entropy pocket in a much larger whole. Infinity has room for rare pockets. Whether that explanation satisfies is its own kind of riddle. Bleak as heat death sounds, entropy is also tender. It gives time a direction and keeps history from smearing into a blur. Because entropy rises, stars shine, rivers run downhill, and living things can borrow gradients to build and remember. Stretch the rule across minutes, and it protects the everyday. Shattered cups don't reassemble. Embers cool rather than reverse into wood. Stretch it across infinity, and it permits bizarre fluctuations. A galaxy whimsically unshuffling, a lone mind blinking into being. The same law holds both the ordinary and the uncanny, depending on how wide you open the door of time. In that double view lies a soft truth. Our moment is temporary, carved against a tide that will one day flatten everything. Within the window, complexity blooms and awareness wakes. Infinity ensures that entropy will win the long game. It also ensures that improbable wonders, including us, get their chance to arise. The arrow keeps pointing forward, and entropy writes the universe's story across a ledger with infinitely many blank pages. Each episode of order is a spark in the drift toward equilibrium, precious precisely because it will not return in the same way. The word infinity causes mischief when it wanders into equations. Mathematicians can treat it as a disciplined abstraction. In physics, an infinity is usually an alarm, a formula that produces an infinite energy or an unbounded value for something measurable is telling you the theory has been pulled past its license. Nature does not appear to deal in actual infinite energy. If it did, every bulb would burn like a miniature star, and heat would flow uphill without complaint. Consider conservation of energy, the quiet bookkeeper of physical law. Energy isn't created or destroyed. It changes costume. A falling ball trades gravitational potential for motion. Friction turns motion to heat. The ledger balances. Introduce infinity and the account explodes. An infinite deposit has no counterweight inside a finite system. It's like trying to pour an ocean into a teacup. The math floods, and the physical meaning spills away. Perpetual motion has always tempted patient tinkerers with dreams of boundless power. Clever wheels, secret weights, cunning magnets, machines meant to feed themselves forever. None survives the first two laws. The first forbids energy from appearing out of nowhere. The second ensures that some energy always slips irretrievably into heat, ruining perfect efficiency. A perpetual motion machine isn't just difficult, it is excluded by the grammar of the universe. Quantum theory can look like a loophole. The vacuum flickers with zero-point jitters. Particles wink in and out. Energy seems to dance on a thin edge of permission. Could we siphon that motion as fuel? The answer remains no. Any scheme to harvest the vacuum's restlessness costs as much or more than it yields. Those fluctuations are background texture, not a bottomless well. Still, infinities appear with unsettling regularity in our best theories. In quantum field theory, summing over all possible energies in particle interactions pushes the numbers toward infinity. Left raw, the result would predict energy densities that make no physical sense. Renormalization steps in to tame this, redefining masses and charges so that the infinities cancel and the leftovers match experiments. It works brilliantly, which is both a relief and a reminder that our models are maps, not the terrain. Classical physics had its own famous misstep. Treat the electron as a point with all its charge concentrated in no space at all, and the electric field near that point becomes infinite. The implied self-energy is infinite too. The world clearly disagrees. Electrons don't sit on stores of bottomless energy. Quantum mechanics soften the picture by spreading the electron into a probability cloud, but questions about self-energy and structure remain fertile ground for deeper ideas. Cosmology brings the same warning in a louder voice. Run general relativity to the beginning, and it points at a singularity, infinite density and temperature at the Big Bang. These aren't physical objects. They're signposts. They say the theory is being asked to handle conditions where its assumptions break down. A quantum theory of gravity, still incomplete, will likely smooth that infinity into something finite and comprehensible. It's worth a gentle thought experiment. If infinite energy were available, the world would be unrecognizable. Engines could run without fuel and without waste, erasing the second law with a wink. Heat could be conjured without cost. Motion could be sustained without friction's tax. Complexity could climb without ever resting, and time's arrow would lose its bite. That this isn't our world is a blessing. The impossibility of infinite energy is what grants meaning to processes that take effort and time. It keeps stars honest, makes engines designs rather than magic, and lets the glow of a room fade into night so that morning can mean something. Infinity, then, acts less like a destination and more like a boundary marker. Push a theory until the numbers blow up, and you've learned where it stops telling the truth. Step back, change scales, add quantum grain or new symmetry, and the infinities often resolve into finite hills we can measure and climb. Entropy's steady rise, the stubborn limits on energy, the rare but permitted oddities over endless time. Together they sketch a universe that refuses both absolute chaos and impossible perfection. Between those two, there is room for a long story, a warm room, a thinking mind, and a sky worth looking into, even if its end is silence. Imagine a kettle that never needed a plug, boiling cheerfully through the night, or a car whose tank refilled itself as fast as the wheels turned. Charming, until you realize that truly infinite energy would make the universe violently unstable. The slightest fluctuation could unleash boundless power and erase structure before it had the chance to take root. Stars would not settle, planets would not cool, chemistry would not linger long enough to learn our names. The impossibility of infinite energy isn't a fussy rule. It's a guardrail that lets complexity stand up and breathe. There are, however, places where nature performs convincing imitations. In a superconductor, electric current can flow with effectively zero resistance. Once set in motion under careful conditions, it can circle for years without a top-up. It looks like a perpetual motion trick, but it isn't. No new energy is created. The system simply wastes almost none. The same goes for certain quantum systems that linger in long-lived, metastable states. They feel timeless, but the meter is still running. Nothing breaks the ledger of energy. Cosmology attracts similar daydreams. Dark energy, the quiet pressure behind the accelerating expansion, sounds like a reservoir waiting to be tapped, but it is not a fuel in any ordinary sense. It is a property of space itself, spread thin and even, not something we can pour into a generator. Within our observable patch, conservation still holds the book. Infinity, once more, is kept at the threshold. Taken this way, infinity is less a treasure chest and more a mirage that teaches caution. When it appears in an equation, it usually means our picture has been stretched beyond its warrant. The problem isn't that the cosmos dislikes large numbers. It is that real energy must be accounted for, transformed, conserved, sometimes hidden, never unbounded. Perpetual motion belongs to stories, not workshops. Not because inventors lack wit, but because the world keeps to rules that even clever gears and magnets cannot unwrite. Infinities expose the seams in our models and whisper the same advice. Look deeper, It's a comfort, too, that the laws drawing these boundaries are the same ones that allow steady starlight, durable galaxies, and a fragile world to balance seasons against time. If the universe began as the evidence says it did nearly 14 billion years ago in a hot, dense state, it's natural to ask whether it will end and how. The answers come colored with different shades of the endless: infinite density, infinite time, infinite reach. One ending imagines gravity reclaiming everything: the Big Crunch. Expansion slows, stalls, reverses. Galaxies drift back together. The sky grows crowded. Temperatures surge. Run far enough and the whole universe shrinks into a state of crushing density and heat, a mirror held to its beginning. The numbers push toward infinity at the final instant. It's dramatic, poised, and currently out of favor, because observations point to an expansion that is speeding up, not down. Still, there's a symmetry to the picture that's hard to forget: an infinite wall at both ends, birth and return. In some tellings, the collapse rebounds into a new expansion, setting a cycle in motion: universes blooming and folding, time stitched into a grand heartbeat. A quieter fate is the heat death. Expansion continues, and everything drifts apart. Stars use their fuel and dim, galaxies thin. Black holes take far longer to fade, leaking their mass away through Hawking radiation. Yet even the largest will eventually evaporate on timescales beyond 10, 100 years. Entropy climbs toward its summit. Over an effectively endless future, energy spreads so evenly that no useful difference remains to drive change. Nothing new organizes. It isn't a curtain drop so much as a drawn-out hush, a dark ocean where the surface barely stirs, an infinity of time with no foothold for novelty. There is a harsher possibility: the Big Rip. Here, dark energy strengthens with time, not merely pushing galaxies apart, but unbinding the bonds themselves. First clusters unravel, then galaxies, then star systems, then molecules, then atoms. The scale of space races to infinity in a finite span. Instead of an endless fade, the story ends with everything torn faster than light can mend, each particle left briefly alone before even that loneliness comes undone. Whether this comes to pass depends on the exact character of dark energy. The range of possibilities leaves room for a rip far in the future, or not at all. These endings show different masks of infinity. The Big Crunch pushes density to the unbounded. The heat death extends time without limit. The Big Rip sends distances galloping toward infinity. None is certain. All make the same point. At the edges of our understanding, the endless waits. There are other paths worth tracing. In bouncing pictures, the universe expands and contracts in cycles without end, avoiding a single origin or finale. In the long twilight of heat death, rare fluctuations might briefly assemble structure again, Boltzmann brains, or even whole patches that look like new universes budding from the quiet. Infinity guarantees that, given enough time, even the strangest page might be turned, though whether those pages belong to our book is still unclear. In each case, infinity is both a tool and a warning. When equations predict infinite density, they might be telling us a theory needs a deeper layer. When entropy stretches into an unending future, it challenges imagination more than it delivers a finished map. When expansion aims toward infinite scale, it asks whether the rules we assumed are steady enough to trust forever. For us, all of this lands with mixed weather. There is fear of endings, of silence, of an impersonal vastness. There is also calm, born of scale. None of these fates sits anywhere near the timelines that cradle our days. The heat death does not darken breakfast. The big rip, if it exists, lives in calendars not yet inked. The big crunch, if it returns to favor, counts epochs beyond counting. Infinity has a way of softening worry simply by stretching it thin. How does the story close? No one knows. Maybe gravity wins, maybe expansion, maybe something we have not yet learned to name. What feels certain is that the endless will be there at the edge, shaping the last scene, whether as density spiking, time unspooling without bound, or distances racing out of every grasp. Talk of endings naturally opens to the question that so many minds love to follow. If the universe is infinite, does every possible event happen somewhere? Do endless versions of you carry out endless variations of your life across a patchwork that never ends? This is the pull of the multiverse, less a single theory than a family of suggestions. The simplest arises from space without boundaries. If space goes on, then matter arranges itself in countless ways, and because there are only finitely many ways to arrange atoms within any fixed region, patterns eventually repeat. Somewhere unimaginably far away, there could be another patch of sky with another Earth and another you, close enough in history to feel eerie, different enough to be new. The odds here, locally, are tiny. Stretched across infinity, the improbable turns patient and becomes inevitable. There are other reasons to entertain the idea. Inflationary cosmology, the same early universe burst that smoothed our sky, can end in some regions while continuing in others, budding bubble universes with different local settings. Quantum mechanics, interpreted through certain lenses, suggests branching realities where outcomes separate rather than erase one another. Not all of these pictures can be true at once. Some may be metaphors that help us think. Others may be physically real without being reachable. The important note, sung softly, is that infinity does not merely live out there. It also lives in how we frame possibility. None of this demands panic. The multiverse does not cheapen a single life, any more than an endless coastline makes a single cove less lovely. If anything, it folds our ordinary days into a broader pattern of how the universe spends its time testing arrangements, exploring configurations, allowing, at least once, this particular combination of atoms to sit in a quiet room and listen, gather the threads. Infinite energy is not a door we can walk through. It is a sign that our math needs mending. Perpetual motion is a mirage that teaches why balance matters. The endings we imagine wear different masks of the endless density, time, expansion, and all of them leave us humbled in the best way. Infinity remains a horizon, not a destination. Each time we approach, it steps back just enough to ask for better questions, gentler models, and more patient measurements. In that conversation, stars keep shining, galaxies keep their slow shapes, and a fragile world learns how to carry silence and wonder together. Inflation began as a quiet fix for several puzzles: the sky's startling smoothness, the near-flat geometry, the way tiny seeds grew into galaxies. In its earliest breath, space is thought to have swelled faster than any light could have crossed it, stretching nearby into far away. In many models, that gentle violence never switches off everywhere at once. It settles here and there, leaving calm pockets like ours, while elsewhere, the swelling continues. Each calm pocket is a bubble with its own local weather of physics, its particular mix of particle masses and forces, perhaps even its own count of dimensions. Picture a cosmic froth, bubbles budding within bubbles, each carrying a private history. Infinity here is not mere repetition, but variation without end. A quilt sewn from pieces, no two exactly the same. Quantum mechanics folds another layer into this fabric. In one reading, the many worlds view, the universe does not choose a single outcome when the small is undecided. It keeps all of them branching rather than collapsing. A coin is both heads and tails until measured. After the measurement, reality holds a version for each result. One path carries the laugh you just let out. Another carries the breath you held instead. Whether this picture is the right one remains debated warmly and well, yet it shows how the endless can slip into the structure of possibility itself. Infinity is not only how far space may reach, it can be how widely outcomes may spread. From there, the mind slides naturally into consequences. With infinitely many places or endlessly branching histories, every allowed story has room to unfold. A world where the dinosaurs never faced their winter. A coastline where no human voice rose from the water. A morning when you reached for a different door and your life curved another way. If the laws can vary from bubble to bubble, stranger scenes open, chemistries we cannot sketch, forms of order we would not recognize as life, but that would recognize themselves. Infinity, in that mood, is not a hall of mirrors, but a boundless studio for creativity. Yet the word everything needs care. An infinite plane ruled by one set of physical laws cannot host what those laws forbid. You may have endlessly many Earth-like patches, but you will not find true triangles whose angles sum to 5. If the laws themselves differ across the quilt, the catalog of possibilities grows wider, perhaps wide enough that nearly anything consistent with logic is realized somewhere. Even then, not every picture we can describe is physically meaningful. Infinity opens many doors. Some still lead nowhere. The sharpest objection is simple and serious. If other universes are out of reach forever, how would we ever know they exist? Science leans on observation and on the chance to be wrong. A multiverse that is, in principle, untestable begins to look less like physics and more like philosophy wearing a lab coat. The counter-argument is that we might still glimpse fingerprints. If our bubble brushed another during inflation, that meeting could have left faint rings or scars in the ancient light, the cosmic microwave background that careful experiments might one day tease out. And even without direct sightings, the idea can explain difficult features of our own room, delicate cosmic balances that allow life, for example, could be selection effects in a vast neighborhood. If many universes exist with different constants, it makes sense that observers bloom only in the rare gardens where conditions are kind. Fine-tuning sits gently in that light. Gravity's pull, the electrons' charge, the rate at which space expands change them a little, and stars might never form. Chemistry might never settle into patience. Life would not have time to look back. If there is only one universe, the kindness of these numbers feels like a remarkable coincidence. If there are countless universes with a spread of settings, it is no surprise to find ourselves in one of the rare life-friendly niches. We couldn't have been anywhere else. Infinity turns coincidence into expectation, though it also asks us to speak carefully about what counts as likely. That care becomes a genuine tangle in an infinite landscape. If almost everything that can happen will happen many times, how do we weigh one outcome against another? How do we compare more often and less often when both occur without bound? This measure problem shadows multiverse talk. Different ways of counting lead to different answers. The way different lenses can make the same coastline look long or short. The mathematics is subtle, the philosophy even more so. Infinity grants possibility, but makes probability slippery. Still, the pull remains. Parallel worlds have lived in stories for a long time, from ancient whispers about countless realms to modern tales of doors between histories. The difference now is that these themes don't live only on shelves. They arise from honest attempts to understand early universe physics and the quantum rules under the floorboards of matter. Inflation, decoherence, and cosmology keep dropping the same hints. Reality may be wider than the slice we can see. Part of the fascination is personal. Everyone has watched a single choice branch a life like a river splitting a round stone. Everyone has wondered how it might have felt to take the other fork. The multiverse gives that wondering a stage large enough to hold it without breaking. Somewhere, perhaps, another you leans into a different song. Somewhere, perhaps, another humanity solved a hard century with softer hands. Real or not, the picture reminds us that the thread we hold is singular and ours. That uniqueness is not lost even in the crowd of possibilities. Infinity doesn't cheapen a moment. It makes the having of it shine. The minds dance with the endless reaches beyond physics. The sideways 8 is easy to draw. The word is easy to say. Holding the idea steady is harder. Brains evolved to count, to plan, to mark sunrises and winters, to notice patterns that begin and end. Forever outstrips those tools. We bridge the gap with metaphors, horizons, oceans, long roads, and with mathematics, which gives rules for handling what we cannot picture. Children meet the idea early in counting games. No matter how high you go, someone can say one more. Infinity feels like the trump card, the biggest number of all. Later we learn that it isn't a number at all, but a way of speaking about unending processes and unbounded sets. Even trained mathematicians move carefully here. Georg Cantor showed that there are different sizes of infinity, some strictly larger than others, and wrote of walking in a landscape where familiar markers had gone missing. Most of us learn to work with the rules, rather than to see the thing itself, the way a sailor trusts charts whose depths he cannot visualize. Psychology backs this up with gentle data. We are good at estimating small quantities and can be trained to manage very large ones. But beyond a point, magnitude blurs. Infinity sits permanently past that point. We handle it with symbols, with limits, with carefully drawn lines on paper. Religion and philosophy add another set of ladders. The eternal and the divine give infinity a face that can be contemplated, even if not grasped. In those frames, the endless is less a calculation than an act of attention, a way to gesture at what exceeds us. Mathematics offers a stricter bridge in the other direction. The invention of limits allowed infinite processes to deliver finite, reliable results. Series that never end can converge to a tidy sum. Infinitely small steps can describe a speed or an area with as much accuracy as we need to land a spacecraft or tune a circuit. The imagination doesn't have to see infinity. It only has to follow the rules that keep it from mischief. Writers play in the same field with different tools. Jorge Luis Borges spun libraries that contain every possible book, a nightmare of completeness that feels like a joke told by the cosmos. Douglas Hofstadter explored strange loops, self-reference that folds back on itself, hinting at infinite descent. Such pieces don't solve anything, but they keep the idea alive in art, reminding us that the mind also circles the endless in stories and songs. Memory and feeling complicate the picture in small human ways. A moment can feel like it lasts forever. A year can vanish in a breath. Waiting stretches. Grief slows clocks. Absorption compresses them. These are subjective infinities, illusions born of attention, but they teach how elastic our sense of time can be. Philosophers like Immanuel Kant argued that infinity belongs to reason rather than to the senses. We cannot perceive it, but we can think it, frame it, argue about it. That is how we use it day to day, never seen, always handled. Neuroscience adds a quiet footnote. Estimating number and magnitude involves regions in the parietal lobe, imagining the endless draws on networks for imagery and language and abstraction. No single spot in the brain houses infinity. It emerges from teamwork, counting circuits, metaphor engines, logical scaffolds. Thinking about the unbounded is like lashing a bridge from many thin ropes. None could span the gap alone, but together they hold. All of this raises a pragmatic question. Do we need to truly comprehend infinity to make honest use of it? The daily evidence says no. We put it to work in calculus and in probability, in signal processing and quantum theory, to design machines and guide ships, and decode light from the first stars. Our grasp is not visual, it is procedural. We know how to approach limits, how to tame divergent sums, how to let an infinite process yield a finite answer. That practical comfort does not erase the strangeness. It just means the strangeness can be harnessed. Set against that background, the multiverse feels less like an indulgence and more like one of the places the idea naturally wanders. If inflation keeps foaming, if quantum events keep branching, if the constants can range across a larger field, then our sky is a local view of a wider country. The open questions are real and worth our patience. How to test what may be out of reach, how to count when counting breaks, how to keep explanation from becoming excuse. Infinity, handled gently, is both a tool and a test. It marks where our maps end and our curiosity begins. What remains steady is the human posture toward it. We lean forward, we draw metaphors, we build instruments that listen for patterns in ancient light. We argue about measure and selection and what it means to say likely in a world that never runs out of tries. We write stories about other paths and then return to the one we are walking, a path no other mind will ever walk in exactly the same way. If there are other worlds, they do not make this one lesser. If infinity holds more histories than we can name, it also frames the rarity of this page, this breath, this room. Whether parallel worlds are only a beautiful speculation or a fact waiting in the mathematics of tomorrow, they distill the essence of the endless. Reality may be larger than any one version, any one history, any one set of laws. Infinity does not promise that everything imaginable will happen. It promises that wonder will not run out. And in the quiet at the end of the day, that is enough, a horizon that keeps its distance, a lantern that does not go dark, a reminder that the mind can rest without finishing the map. We lean on quantum mechanics every day, even though it refuses to sit neatly inside anyone's intuition. The mind manages by trading pictures for procedures, symbols, rules, a steady hand with limits, pushing imagination just far enough to bring back answers that match the world. Infinity lives there as an orbit rather than a possession. We circle it with proofs and parables, with careful algebra and small, glowing metaphors. It also exposes something tender about us. Our ancestors could hunt and plant without ever naming the unbounded, yet the species kept glancing past the fenced stars beyond counting. Days that seemed to spill forward without end. Numbers that rise like steps with no landing. Infinity reveals a restlessness in thought, a refusal to stop at what fits in the hand. We may never hold it, but reaching for it teaches us the flexibility of our own minds. Mathematics turns the endless into a usable tool. Metaphor makes it vivid. Imagination, being playful, keeps us from fear. The dance matters more than the capture. Infinity often answers by asking better questions. Each time we think we've pinned it down, it slides between our fingers and leaves a riddle behind. Zeno of Elea understood this long ago. To cross a room, he said, you must first go halfway, then half of what remains, then half again, without end. If there are infinitely many steps, how do you ever arrive? In the race between Achilles and the tortoise, the hero reaches the tortoise's last position again and again, while the tortoise slips a little farther each time. By the logic of endless subdivision, Achilles never overtakes the slow one. Real legs refute the puzzle. Still, the paradoxes uncover a seam between how motion feels and how division behaves. The modern cure is gentler than it is dramatic. The sum, 1, 2 plus 1, 4 plus 1, 8 plus, approaches 1. An infinity of smaller and smaller steps can take only a finite time. Achilles passes. The walker arrives, yet the unease lingers usefully, a reminder that infinity can hide in the space between two tiles on a floor. Later, David Hilbert built a hotel with infinitely many rooms and asked us to check in. Every room is full, and still the manager finds space. Move the guest in room 1 to room 2, room 2 to room 3, and so on. Now, room 1 is free. Bring a bus with infinitely many new guests. Shift everyone from room N to room 2N. The odd rooms open like lanterns along a corridor. Subtract infinitely many occupants, and you may still have infinitely many left. The puzzle doesn't break arithmetic. It shows how arithmetic changes in the presence of the endless. Full and room for more can be true together when counting never stops. Philosophy wrestles with its own loops. If every event needs a cause, and every cause leans on an earlier cause, the chain walks backward forever. Do we rest it on a first cause, or accept an infinite regress with no anchor? Knowledge feels the same pressure. If every belief demands justification from another belief, the staircase sinks without a bottom step. Infinity, in these mirrors, is a trap door under the neat idea that explanation always terminates. Cosmology collects paradoxes the way shorelines collect driftwood. Consider an eternal past. If infinitely much time has already unrolled, how did we ever arrive at now? The metaphor of climbing from the bottom of an endless ladder doesn't quite fit what physics means by past, but it carries enough weight to push many thinkers toward a beginning like the Big Bang, rather than a truly boundless past. Another old thorn is the bright night puzzle. In an infinite, static universe with stars evenly spread, Every line of sight would end on a star, and the sky would blaze. The night is dark because stars live finite lives. The universe expands, and distant light is stretched and dimmed until it slips from view. Infinity must be reconciled with observation. Otherwise, it writes checks the sky does not cash. Probability joins the chorus. Flip a fair coin forever, and every finite pattern appears somewhere. 1,000 heads in a row, perfect alternation, any name encoded in bits. Over the infinite, the border between certainty and chance fades into a fog of almost sure. The same intuition fuels multiverse musings. If the universe is large enough or branches widely enough, everything allowed by the rules happens not nearby, not often, but somewhere. Physicists, for their part, treat infinity like a fire alarm. Mathematicians can embrace it and build careful kingdoms upon it. In physics, an infinity usually means the theory was pushed past its license. General relativity is a masterpiece. Gravity as geometry, planets and photons escorted along curved paths, a universe whose large-scale structure follows from the distribution of matter and energy. Yet inside its equations hide singularities, places where density and curvature soar to infinity. At a black hole's center, the math insists, matter collapses into a point where the fabric stops behaving like fabric. At the beginning of cosmic time, the same blow-up appears as an initial singularity. These are not triumphs. They are signposts, saying, new physics required. Quantum field theory stumbles differently. Treat particles as ripples in fields and try to compute interactions with naive sums over all possible energies. The integrals blow up. The electron's self-energy, its own field's contribution to its mass, becomes infinite if you let the theory wander without a leash. Renormalization ties the leash. Redefine masses and charges so the infinities cancel in combinations we can actually measure. The method works outrageously well. Predictions match experiments to many decimal places. Some still wince at the aesthetics dust under the rug, they say, but in practice, the dust is encoded and accounted for in a way that makes the rug fit the room. The unease remains, pointing at a deeper theory in which the cancellations are a shadow of something more natural. Where gravity and quantum meet, the alarms all go off at once. Quantizing gravity the same way we quantize the electromagnetic field breeds divergences that refuse to be tamed. The theory is non-renormalizable. Black hole cores and the first instance of the Big Bang are precisely the places where both quantum effects and strong curvature matter, and precisely where our two proud frameworks fail together. New bridges are being built, string theories extended objects that soften points into loops of vibration. Loop quantum gravity's discrete weave of space. Other, quieter roads that change what space-time means at small scales. None is yet the last word. The infinities are the map's edge. Infinity complicates cosmology's bookkeeping as well. If space is infinite and matter isn't vanishingly thin, then there is infinite matter, infinite galaxies, infinite energy spread through an endless stage. In such a theater, probability becomes a subtle art. How do you compare numbers of things when both counts are unbounded? This is the measure problem, and it haunts scenarios with eternal inflation or infinite spatial extent. Depending on how you slice the infinite loaf, different outcomes seem more or less likely. A reminder that counting is not neutral when the set has no end. Between all these alarms and puzzles, the mind still finds quiet ways to keep working. We do not need to picture infinity to use it. We only need to agree on rules that do not betray experiment. Limits tame endless processes into finite answers. Unvergent series. Let us treat unending sums as totals you can put to work. In practice, this modest stance is powerful. Bridges stand, orbits hold, signals compress, circuits hum, telescopes focus, light that left before cities were born. The multiverse, whether from eternal inflation's froth of bubbles or quantum theory's many branching book of outcomes, extends the mood. If other regions exist with different constants of nature, the fine-tuning that makes chemistry and stars possible may be a selection effect rather than a cosmic coincidence. We live where life can live because nowhere else could we be. Even so, an endless landscape threatens to swallow explanation in a soup of anything happens somewhere. That is why indirect tests matter. Scars in ancient light from collisions between bubbles, patterns in fluctuations that favor one inflationary story over another, internal consistency that leaves fewer arbitrary choices. Infinity asks for restraint, even as it promises room for every dream. Zeno's steps still echo, Hilbert's corridors still expand, infinite regress still tempts and warns, Olber's dark night still teaches, coin flips still blur certainty at the edges. General relativity still bows near singularities. Quantum fields still demand renormalization. Quantum gravity still waits for a language that calms the numbers. Through it all, quantum mechanics keeps doing its work, despite our unease. The way a familiar song can move you, even when you cannot sing harmony. We operate with symbols and rules and careful habits of thought. We use metaphors to carry weight. Our eyes cannot lift. We let imagination roam, not to conquer the endless, but to travel farther within ourselves. The real gift of infinity may be the way it reveals our inner architecture. We are finite beings, equipped with tools that can aim past finitude. Children learn that biggest number is always followed by +1. Adults learn that infinity is not a number at all, that there are even larger and smaller flavors of endlessness, that some infinities cannot be listed while others can. Psychologists and neuroscientists find that the brain estimates magnitude well up to a point and then falters, so we lean on metaphor, horizons, oceans, long roads, and on formal methods limits, cardinalities, measures to keep going. Religion and art find their own angles. Eternity as a name for the divine, a symbol for transcendence. Stories that imagine infinite libraries or strange loops to make the idea tactile enough to haunt. We do not have to master the endless to be enlarged by it. Each failed attempt to grip it leaves behind a tool we can keep, a proof, a picture, a line of verse, a device that turns sunlight into power. Infinity is not just out there in the number line or stitched into the sky. It is here, in the way attention can widen, in the way we can imagine what we cannot see, in the fact that symbols on a page can reach farther than the hand that wrote them. When physics runs into infinities, we do not declare defeat. We take them as directions to revisit our assumptions, change scale, refine the map. When philosophy finds regress, we reconsider what counts as a foundation. When cosmology brushes an endless horizon, we remember to separate what can be seen from what may exist. The paradoxes, maddening as they are, have been generous. Zeno's troubles helped inspire calculus and the modern idea of limits. Hilbert's Hotel clarified what it means to compare infinite sets. Infinite regress sharpened our standards for explanation. The Bright Night Puzzle taught us to read the age and expansion of the universe in the darkness between stars. Even the measure problem nudges us toward more careful definitions when we talk about likelihoods that live on an infinite stage. Paradox may be the native language of the unbounded. Learning to listen has been part of our education. So, the endless returns, not as something to defeat, but as a horizon that keeps its distance while giving light. We work near it. We let it bracket our questions. We accept that full can coexist with room for more, that an infinity of steps can take a finite time, that a theory can be both wildly successful and, obviously, incomplete. We keep walking toward the line where equations blow up, not to break ourselves on it, but to find the better story waiting just beyond. And every so often, in a quiet room, we allow the mind to stop trying to draw the whole of it and instead enjoy the strange kindness of the attempt. How do you call something likely when both it and its alternatives occur without bound? In the eternal bubbling picture of inflation, where new cosmic pockets keep budding, the question sharpens into a knot. Physicists call it the measure problem. When the tally is infinite on every side, how do you weigh one outcome against another without the scales breaking? Counting per volume, per time slice, per bubble lineage, each choice tilts the answer. Without a principled measure, prediction dissolves into fog. Probability needs a way to say more often than, and infinity keeps moving the yardstick. This unease with infinities isn't prudishness about big numbers. It's a practical instinct. In physics, an infinity is rarely a discovery. It's usually a warning light. The math is telling you the map has reached its coastline. Within the city, the energies and distances where the theory was born. The streets are accurate. The address is findable. Push the map out onto the open ocean, and the symbols stretch and overlap until north and south argue. The task is not to declare the ocean imaginary, but to craft a better chart for that water. Several crafts are underway. One boat sails under the flag of string theory, where the smallest actors aren't points but tiny vibrating loops. Points, when forced to carry charge in mass, make fields blow up at zero distance. Strings spread those properties over a wisp of length and calm the storm of infinities. Interactions that would have punched holes in the fabric at point-like scales become gentle ripples when the participants are extended. Another boat is loop quantum gravity. There, space and time are not endlessly smooth. They are woven from discrete links and nodes, like a fabric whose threads have a finest twist. Curvature cannot soar to the truly infinite if there is a smallest unit to bend. In place of singularities, those bad words for "here the math gives up" come finite structures with calculable behavior. Even without a completed bridge between the quantum and the geometric, hints keep arriving that a better scaffolding will tame the places where the old beams creak. Some models of black holes replace the central infinite density with a finite region where quantum pressure counteracts collapse, a bounce rather than a dead end. Some early universe pictures smooth the Big Bang into a transition from a prior phase, avoiding a beginning made of infinity. Time curves through rather than slamming into a wall. These moves change the question from "how did the world swallow an infinity?" to "what regular process did we misname as impossible. Practical puzzles rhyme with the grand ones. Quantum field theory, when allowed to sum all possible vacuum vibrations, hands you an energy so huge that the universe should have torn itself apart long ago. Observations whisper a very different number, a tiny positive value, the dark energy driving today's acceleration, a mismatch of such staggering size that people call it the worst prediction in physics. The gap is more than an embarrassment. It's a clear sign that the way we've used infinity in the calculation has missed the point. Somewhere between the idealized sum and the measured sky lies the right story. There is another reason to be careful. Infinity can erode explanation. Give a theory permission to shrug and say everything happens somewhere, and the notion of prediction weakens. If any outcome can be justified after the fact by pointing to an endless catalog, falsifiability fades. Science does not need rigidity, but it needs edges, statements that can, in principle, be proved wrong. Infinity, left unguarded, washes those edges smooth. So the habit becomes constrain it, reinterpret it, or remove it wherever it does more harm than help. Yet the discipline is not contempt. There is humility in the way physicists treat the endless. Each infinity is a bright sign over a door. Here, your knowledge ends. Black holes, the early universe, the vacuum's energy. Each arena where the math explodes is also a map to where the next theory should start. In that sense, infinities are not obstacles, but beacons. They mark the mountain passes. Whether the future belongs to strings, loops, something we haven't named, or a weaving of many threads, the aim is simple. A world picture where the numbers stop shouting and start speaking in measured tones, where densities, curvatures, and energies remain finite, even in extreme regimes, where probability can be defined without a wink when the stage is very large. Until that picture settles, prudence rules. Treat infinities with suspicion. Test them like you test a rope over a canyon. Keep your footing on the parts of the path that hold. There's comfort in naming the horizon honestly. Infinity is not a reading on a meter or a thing you can put in a jar. It's a direction, a boundary drawn by thought, a silhouette that appears when finite tools try to encompass a whole too broad to fit. When it breaks physics, it is not nature failing. It is our current language confessing its limits. The cracks are not shameful. Light coming through is the point. The word itself wears two faces. One is unsettling, equations that run away, futures that fade into cold quiet, a space that will not fold neatly into the cupboard of comprehension. The other face is gentle, no last wall, no sharp stop, a continuity that softens the fear of endings, abyss and embrace, warning and reassurance. Finite bodies, wrapped in finite days, feel both. Stand beneath the night and you get a first taste. The stars are too many to count. Beyond them lie more dots, and beyond those, more. Let the thought of no end sit too close to the face, and the mind reels. Pull back a little, and it soothes. No final cliff, only curve. No last page, only room. The ocean does not halt at the horizon. It simply continues beyond your sight. The endless offers companionship to those uneasy with goodbyes, continuity as a quiet mercy. Mathematics, for its part, reveals a personality to infinity that is more playful than monstrous. In Hilbert's Hotel, full and more share the same hallway and get along. Calculus turns infinite ladders of fractions into single, neat numbers. An unending division of steps can add up to a finished crossing. These oddities are not cheap tricks. They are rules for turning the unbounded into workable results. The same rules behind bridges that hold, orbits that keep time, and circuits that hum at just the right pitch. Usefulness and elegance share a table with the endless. They drink tea together in the afternoon. Physics treats infinity sternly, but lets it inspire. Black holes, with their rumored singularities, become laboratories exquisite enough to bend light and slow time, allowing us to test gravity where it is most itself. The accelerating expansion stretches distances toward unreachability, a loneliness on the largest scales that is sad in one mood and liberating in another. There will always be more is not only a limit, it is also an invitation. New forms, new questions, new corners of darkness to gently illuminate. Meaning threads through the conversation, a life bounded by a few decades, set inside a frame that may have no border, can feel like a drop in an endless sea. That drop glows more brightly for being brief. Finitude gives weight. Infinity gives context. Without the endless, we might not recognize the preciousness of the fleeting. The sunset matters because it ends. The night matters because it does not. Traditions reach for this in different languages. Infinity names the eternal in theology, the unbounded in poetry, the transcendent in philosophy. To call something infinite is to say it resists fences. It spills over the edges of our ordinary categories. You cannot hate a river because it flows. You can only step in, drink, and learn its currents. The same goes for the unending. It is not only a concept to calculate, but a posture of attention, a way to feel the wideness. No other animal, as far as we know, worries about whether time has a last second. Birds migrate across an arc of sky and do not ask if sky has walls. Ants carry food in lines and do not picture ladders that sink without a bottom rung. Humans do. That ability to imagine what cannot be contained is as beautiful as anything we build. The skill itself is a candle in the dark. Science and art meet here. An equation writes an infinite series that converges. A poem writes forever and makes you feel what the number cannot show. Music wraps, loops inside, loops until the ear senses a hallway without doors. A painter fills the canvas edge to edge and still hints at a world beyond the frame. Each craft circles the same idea with different steps, holding hands across a gap that neither can bridge alone. Paradoxes remain old friends. Zeno's steps, Hilbert's rooms, the multiverse is branching. Each refuses to sit still inside common sense, and each yields something useful when treated with care. The endless is not there to be captured. It is there to be lived with, like a horizon that recedes as you walk, and yet guides your path by being steady. The real trick is to let paradoxes inspire without letting them excuse, to refine models when infinities appear, not to hide behind them. Endings in ordinary life feel hard and definite. The last page of a book, the last bar of a song, the last breath of a loved voice. Infinity does not erase these. It places them in a room that is larger than grief. Space may continue, time may stretch, possibility may unfold in ways we do not get to witness. That does not make small moments less. It gives them a setting where they shine, like a candle noticed more for being a point of light in a wide night. The double nature of the endless is what makes it so rich. It can frighten with scale and comfort with continuity. It can puzzle with contradictions and inspire with scope. It is beyond comprehension and yet present in daily acts, counting the steps to the mailbox, watching steam rise from a cup, looking up. Its beauty lies in the way it refuses to be one thing. It is a challenge and a consolation, the sharp edge of mystery and the soft curve of wonder, the unreachable and the familiar. Across this journey, infinity has traveled with us like a shadow, sometimes cool, sometimes warm. Zeno's half-steps, Hilbert's shifting guests, singularities cloaked in horizons, ladders of numbers that never run out, universes that may be one among countless. Each scene has been a different mask on the same face. Sometimes the masks broke our equations and sent us back to the drawing board. Sometimes they gave us tools, limits, renormalization, new geometries to turn endless processes into finite outcomes. Always they widened imagination, which is the secret engine of understanding. Infinity does not belong to one discipline. It moves easily through mathematics, philosophy, physics, and the inward rooms of the mind. A mathematician meets it in cardinalities and limits. A philosopher sees it in regress and eternities. A physicist feels its pressure at horizons and in theories that diverge. A poet, an artist, a dreamer hears it as openness, as a sky that keeps going, as love without edges. The idea is one, though the costumes change. It is also our mirror. We are bounded creatures, short lives, partial senses, minds tuned to patterns with beginnings and endings, and yet we reach as naturally as breathing. The reaching is our signature. We don't comprehend infinity, we converse with it. That conversation admits ignorance and promises growth. Knowledge won't end, it will keep unfolding. There is humility in that posture, a bow to the scale of what is, and a promise to keep learning. Even the biggest numbers bow to scale. The observable universe dwarfs any catalog we can speak aloud. Beyond the observable may lie more without limit. Forward in time lie spans so long that black holes fade into warm whispers. Down in size lie domains where space and time may stop being what we mean by those words. Infinity stretches in every direction, and the proper response is not fear but wonder. To know we are small, and to love the fact that we live inside something so large. Infinity softens perspective. 2. Endings sting. The last line of a letter, the last day in a home, the last leaf in a season, the endless whispers that endings might be doorways, not bricks. Time keeps moving. Even if our part is brief, the stage remains. Infinity does not deny finiteness. It sets a background that invites calm. And it bears repeating. Infinity is not always literal. Often, it is a flag marking the limit of a model, a sign that better language is required. When Einstein's equations insist on infinite density, they're shouting that the continuum is being asked to do a job for which it wasn't hired. When quantum fields yield infinite energies, they're telling us our sum has been taken beyond its valid range. These are not failures of nature, they are invitations from it. The map ends. Please draw more carefully. What the endless gives back is patience, perspective, humility. No one solves infinity. We learn to work beside it. We shape it into tools. We respect the places where it won't be shaped. We hold lightly the conclusions that depend on it. We're reminded that our stories unfold beneath a sky that recedes each time we lift our eyes, that our problems occupy rooms in a house with more rooms than we will ever walk. That is not discouraging, it is energizing. The beauty of the endless is precisely that it refuses to be boxed. There won't be a final equation that erases every instance of infinity, a last word that folds the horizon into a pocket. The horizon moves as we walk. The more we learn, the more there is to learn. That is not a defect. That is the heart of curiosity. It guarantees there will be more explorations, more refinements, more gentle shocks of surprise. In the bedroom hush of night, when you tilt your head to the window and see a handful of stars, the endless is not terrifying. It is serene. It is a canvas that cannot be filled, and so it makes room for questions, for patience, for the small kindness of letting a day end without demanding that the story be finished. You do not have to grasp it. It is enough to know it is there, to know that reality is larger than any plan, larger than our worries, larger than our most fluent speech. That knowledge is a kind of peace. So the endless is not a problem to defeat, but a companion to travel with. It is the soft assurance that there is always more time in some directions, more questions in every direction, more space in which new ideas might take their first breath. Our finite stories unfold against that quiet backdrop, and they are brighter for it. To meet infinity is to remember that life is a spark inside the wide dark, and the spark gathers beauty from the contrast. Close your eyes now. Let the numbers, which love to climb, find their own pace somewhere you do not need to follow. Let the horizons keep their promise and keep their distance. Let the riddles deepen in a way that soothes rather than stirs. The goal was never to capture the endless, only to walk beside it for a while, to feel how it enlarges the room without crowding it. As long as the idea remains, so does the invitation to wonder, to imagine, to reach. And then, like stars thinning toward dawn, the words grow quiet, the questions dim to embers, and the sky, still wide, still patient, waits just beyond your breathing.